Hi everyone, this is Sushant from Unity Devs. Welcome to our today's session on how you can use batch processing in Mule 4. So guys, before we begin, I'm going to brief you about the agendas in today's session. So guys, these are the list of topics which we are going to cover one by one as a part of this playlist. Okay, so let's get started with our first topic. What is batch processing basically? So guys, from the definition only it's clear. Batch processing is used for asynchronous and reliable processing of large chunks of data, and the components are batch job, batch step, batch aggregator, and on-complete phase. So these are the four components which helps to perform the asynchronous processing of those large chunks of data which batch job receives from the input. So whenever input record hits the batch job, so firstly batch job automatically splits that data and transfer that data into the persistent queues. Okay, and let's say for some reason your application stopped or some crash happened, so in that case those persistent queues will be very helpful in resuming your process from where it stopped. So that's how it is very helpful when we are processing a large chunks of data in asynchronous way. So guys, this is the batch process architecture. So from this diagram you can clearly see we have a message source from where we receive the messages, records, and after that there's a message processors where you can apply any logic. You can convert that input message into a particular MIME type, into a particular data type, and after that you can see one batch job scope is there. Inside a batch job scope you can see batch step scope, another batch step scope, and after in the end on complete phase. Okay, so this is the architecture. In next slides I'm going to show you how this whole architecture basically works. So guys, as we discussed earlier, in batch job scope, batch job basically splits that input data and transfers it to the persistent queue. And once it transfers to the persistent queue, after that it will be received by the batch step for processing. Okay, so once it's transferred to the persistent queue, it will be received by the batch step for processing, and then it will process those records, and in the on-complete phase you will get the summary of records, how many records has been processed, how many are failed. So let me show you one diagram where you can clearly understand what I'm saying. So guys, as you can see in this diagram, we have an input which acts like a message source, and after that a load and dispatch phase happens, okay, in which those messages are split and transferred to the persistent queue. And after that processing phase will start, which is basically a batch step phase, and in the end we have an on complete phase where we get the summary of all the records which are processed previously, how many are failed, how many are passed, how many are loaded. So all the summary of records we will get. You can also see this diagram. So this whole diagram shows a batch job scope. So in this batch job scope you can see once we started receiving the records, it will be transferred to the queue first. Okay, after that it will be received by a particular batch step. We can add as many batch steps we can based on our requirements. So once it's transferred to the queue, it will be received by the batch step. Once those records will be processed by a particular batch step, it will be transferred to the queue again, and from there all again another batch step will process those records which are transferred by batch step 1 to a queue. Again, after processing those records by a batch step 2, it will be a transfer to the queue. And after that, again, those records will be picked up by the batch step 3. Okay, so you can add as many batch steps as you can based on your requirements, based on your use case. Okay, so let's move on to the next topic, common uses of batch processing. So guys, these are some of the common use cases where batch processing, basically we use batch processing. Okay, so when there is a need to synchronize data between a business applications, such as syncing contacts between NetSuite and Salesforce. Okay, so in extracting, transforming and loading information into a target system, such as uploading data from a flat file to some end system like Hadoop. Okay, handling, for example, handling large quantities of incoming data from an API to a legacy system. So these are some of the most common use cases where we use the batch processing basically. Okay, syncing payment data from Workday to Salesforce, syncing user data from archives to Salesforce Marketing Cloud, where basically large chunk of data is involved, we basically use batch processing. Okay, in simple words. So in this architecture, you can clearly see we have a message source from where incoming message arrives. Message process can be anything. It can be a transform message, which helps you to convert that input message into a particular MIME type, which is compatible with this batch job. And after that, you can see this batch job scope. As we discussed previously, in this phase, we used to load those records into the persistent queue. It is also known as a loading and dispatching phase. And after that, inside a batch job scope, we have a batch steps where we used to apply our business logic and call end systems inside the batch aggregator based on the batch aggregator size, how many records in a single hit you want to transfer to that particular end system. Okay, and after that, based on your use case, how you can handle those failures, you can add multiple batch steps based on your requirements. It's optional, but you can add based on your use case. Okay, and in on-complete phase, we used to get a summary of all the records which has been processed in the processing phase. So batch step phase is basically the processing phase. Okay, so in on-complete phase, you will get the summary of all the records which has been processed previously. How many records are filled, how many records are loaded, how many records are passed. So all the information you will get on the on-complete phase, guys. So let's move on to the next topic, batch processing architecture. So guys, let's move on to the next topic, which is batch processing components. So guys, as we previously saw in the batch process architecture, we used to have a batch job scope, we used to have a batch step. Okay, we used to have a batch aggregator inside the batch step, and after, in the end, you have on complete phase. So these are the typical components we have inside the batch process. So in Anypoint Studio, let me show you how those components looks like. So guys, you can see this batch process. So this is the batch job scope, this is the batch step. Okay, where we used to write some business logic and call end system. Okay, and this is the on complete phase where we used to get a summary of all the records, how many records are processed, how many filled, how many loaded. Okay, and this is the end of the flow basically. Okay, so batch job, batch step and on complete phase. So these are the components which are a part of this batch process. Okay, so guys, let's move on to the next topic. What is load and dispatch phase? Okay, so guys, as I explained you previously, where records are loaded into the persistent queue, okay, in the form of blocks, and that batch block size will be determined by a batch job scope. Okay, in batch job scope we can specify a batch block size, and in the form of blocks, those records will be transferred to the queue. And upon transferring it to the queue, after that, batch step will receive those re records in the form of blocks. Okay, and with the help of multiple threads we can process those records inside the batch step. So load and dispatch phase is nothing, it's just a phase where records in the form of blocks are loaded into the persistent queue. That's it. Okay, so our next topic is processing phase. So processing phase is nothing but a batch step phase where processing of those records happens with the help of multiple threads which system has. Okay, so based on a particular business logic, whatever business logic you have based on your requirements, you can apply those business logic and process those records. Okay, so that's basically a processing phase. So processing phase is basically a part of this batch step phase. Okay, where all the processing happens. And on complete phase, I think you already know, I showed you. This is the incomplete phase where you will get all the summary of a records. How many records are filled, how many records are processed, how many records are loaded, and more information about this. What and all things are happening, what is the batch job instance ID. Okay, so all that information you will get in the on-complete phase. I will show you all these things with the help of POCs in upcoming videos. So guys, let's move on to the next topic, which is basically component configurations. How you can configure these different components and what and all fields are involved which you need to configure while executing a batch process. So guys, these are the different fields we use to configure while executing a batch process. Okay, and we will see by varying these fields how batch process works with the help of multiple use cases which I have already configured in my Anypoint Studio. So practically we will perform a POCs in upcoming videos and we will see how by varying these different fields how batch process impacts, how batch process works. Okay, in this video we will just cover a basic part. Okay, what is the use of this field, architecture, components, phases, so all that stuff. In upcoming videos we will cover POCs about on this different fields, how we can configure them, and how by varying them how batch process works. So guys, our first field is batch block size. So from the definition, it is basically the number of threads treated as chunks and processed by one thread. Its default value is 100. Okay, so let me go to the Anypoint Studio and show you where it is. So guys, if you click on the batch job scope, you will see this field. So here you can see. So if you will not provide any value here, by default it will consider it as 100. So what does it mean? What does it mean by 100 or 1? It means one block will be assigned to a one record if this batch block size is 1. Okay, now let's say batch block size is 100. It means 100 records will be allocated to one block. Okay, now let's say batch block size is 50. It means 50 records will be allocated to one block. So let's say if we are getting 100 records in the input and let's say our batch block size is 50, it means 50 records will be allocated to one block. So there will be two blocks which will be created. So when we will get those 100 records, okay, it will create two blocks in the batch job scope phase. Okay, and in the batch step it will process those two blocks with the help of multiple threads. So in my computer I have 16 threads. So those 16 threads will help to execute those two blocks parallelly. So one thread will execute one block at a time. Another thread will execute another block at a time. Okay, because we have only two blocks. So if you increase the batch block size, let's say instead of 50, you give batch block size as 10. So 10 blocks will get created for those 100 records. Okay, and those 10 blocks, it will execute those 10 blocks parallelly. Okay, one thread at a time will execute one block, another thread will execute another block parallelly, and so on. So guys, I will explain you more when we will be performing one POC on this. With the help of one real example, I will show you how this whole process works. For now, I am just making you familiar how you can configure these fields and what are the use of these fields. Okay, in POC part you will get more clarity when we will perform a practical on this. Okay, with the help of the use cases which I have configured here. Okay, so just for your understanding again, batch block size is nothing, just the allocation of records to a particular block. So let's say again, let me explain you. Let's say we have 10 records here. Okay, and let's say we have batch block size as 1. It means 10 blocks will get created, and those 10 blocks will be executed parallelly with the help of those threads which you have in your system. Okay, so while doing POCs I will explain you more on this. Okay, so guys, the next field is batch job instance ID. So from the definition, by default the batch job instance ID is treated as a UUID automatically by Mulesoft, but this field can be used to override a default behavior. Okay, you can specify your ID also, but by default it's a unique ID which specifies each batch instance uniquely. Okay, let me go to the studio and show you where this field is. So you guys, you can see this is the field. So if you will, even if you will not provide it, by default batch process will allocate one variable to it, and that will uniquely specify a particular batch instance at a time. So it is basically to uniquely identify a particular instance, a particular, I can say a particular moment in which that particular batch processing is executing those records which are sent by the message source. Okay, so guys, the next field is scheduling strategy. So guys, from the definition, scheduling strategy decides more than one batch instance will run in case others start before current batch job finishes. So let's say at the same time batch process is triggered by a multiple users. So how batch processing will work at the same time? Okay, so there comes the scheduling strategy. Okay, that how your batch processing will work when multiple users called your batch process, when multiple message sources called your batch process at the same time. Okay, so we have two types of scheduling strategies: ordered sequential and round robin. Okay, we will understand more on the ordered sequential and round robin while doing the POCs. Okay, you will get more understanding when we will doing the POCs. So in upcoming videos, I will cover these two things with the help of a practical use case. So guys, our next field is max field records. So guys, from the definition you can see, basically Mulesoft has the three options for handling a record level error: finish that particular processing, continue that processing, or continue that processing until a batch job accumulates the maximum number of records. So basically these types of behavior are controlled by the max field records field. Okay, so let's say if we configure max field records field as 0, So if we configure it as 0, in that case, let's say we have 10 records in the input, and one of the record fails in the batch step phase. The first two records processed successfully and the third one fails, let's say. So in that case, this whole batch processing will stop executing. Okay, because max filled records value is 0. So if max filled record value is 0, if we get any error while executing those records, even for any one record, this whole batch process will stop executing the remaining ones. Okay. Now what if value of max filled record is -1? Okay, so from here you can see corresponds to continue processing. Okay, so let's say we have 10 records. Any one record fails. Let's say after processing 2 or 3 records, fourth record fails. So it will continue processing the remaining records. It will not stop. Okay, it will continue processing those records until all the records finished processing. So it will not stop like previous case. So that's why if we configure batch max filled records as -1, it will not stop until it finishes all the records which we are getting from the input message source. Okay. Now let's say if we pass some positive integer. Okay, so from the definition you can see it corresponds to the continue processing until batch job accumulates a maximum number of filled records. Okay, so let me show you how it works. So guys, in this diagram you can see, let's say we have max filled records as 2 and the number of records we are getting from the input is 5. Now let's say first 2 records processed successfully in the batch step phase, and third record fails, and again fourth record fails. Then once that fourth record fails, it will not process the fifth record because already 2 records are filled, as we configured max filled records as 2. Okay, so whatever number you will configure in the max filled record, if same number matches the failure count, then batch processing will stop. Okay, we will understand more when we will doing the POCs in the upcoming videos. So guys, you can clearly see max filled record has 3 values: 0, -1, and a particular positive integer, and any particular positive integer. So guys, our next field is max concurrency. So guys, from the definition it is clear: maximum number of threads to start process different blocks in parallel. So by default its value is 16. Okay, so let me show you. So you can see this is the field maximum concurrency. So in this field you can specify a number. That number denotes to how many threads you want to allocate to execute a particular batch process. Okay, let's say if I configure it as 16. Okay, so it will execute 16 records parallelly from each block. Okay, let's say we have 16 blocks. Okay, and we have 16 threads. So each thread will execute one record from each block. So parallelly 16 records will process at a time. Okay, so this is basically the maximum concurrency. So guys, the next topic is max age and time unit. So from the definition you can see batch process retains the history of batch instances in a temporary directory in Mule runtime. So by default retention policy is set to 7 days. So a monitor process will remove the temporary data that has met the expiration criteria using the max age and time unit that can change the default behavior. So guys, as I showed you previously, that in the loading and dispatching phase, we used to transfer our records to a queue. Okay, and those queues will denote to a particular batch instance, for which batch instance that particular queue belongs to. So let's say our Mule system crashes while processing some records, and few of the records are not able to process. So in that case, we already have those records history maintained in a particular batch instance queue, a persistent queue. Okay, so this max age and time unit denotes for how much time you want to retain those records in your system. So if retention policy, you will keep it as 7 days. So till 7 days, let's say your system crashes till 7 days. So after 7 days, those records will erase from your system. So to continue processing those records, your Mule system should start before 7 days so that it can execute those records which are present in your particular batch instance queue. Okay, so that's why we used to keep these fields while processing the records with the help of a batch process. So we used to configure. Let me show you how you can configure. So guys, in batch job scope, you can see a history field. So in this, you can configure as per your choice. You can discuss with your architect, your solution architect, your principal architect, and configure this age. Okay. So let's say if you want to configure it as 5 days, it will keep those batch instances for 5 days. Okay. So guys, our next topic is accept expression and accept policy. So from the definition of accept expression, to process only records that evaluates to true. If the record evaluates to false, the batch step skips the record and sends it to the next one. In other words, the records with an accepted expression that resolves to false are the ones that Mule filters out. Okay, so let me show you. So guys, if you click on the batch step, you can see this field called as accept expression. So guys, let's say we have 10 records in the input, 1 until 10. Okay, 1 to 10. And let's say we don't want to process record number 5. So we can give a condition here that hey, we don't want to process record number 5. Okay, we can give it like payload. You need to give like this. Okay, payload dot age should not be equal to 5. Okay, so if that age parameter is not equal to 5, it will process it. Okay, but if it is equal to 5, it will not process it. Okay, so that's the easiest one. You can just filter out the records basically based on the accept expression. So it will not process this record, and this record will be passed to the next batch step. You can configure multiple batch step as I showed you previously, like this. So you need to drag this batch step and put it here. So by this you can use multiple batch steps in the batch process, and that record which has not been processed in the first batch step will be passed to the next batch step, not directly, but first it will be transferred to a queue, and from queue this batch step, another batch step, will listen to that record and process it. Okay, so guys, our next field is accept policy. So from the definition, it is written batch step to process only those records relative to the value of accept policy attribute. Evaluates to true, or refer to the table below for a list of available values for a accept policy. So guys, in this table you can see accept policy has 3 values. The first one is no failures, the another one is only failures, and the third one is all. So from the definition, if we have accept policy as no failure, so batch step processes only those records that are succeeded to process in all the preceding steps. Okay, let me show you. So guys, let me explain it to you with the help of one example when we used to configure accept policy as no failures. Okay, so guys, let's say we have 10 records in the input. Okay, and let's say out of those 10 records, the last 3 records failed to process in this particular batch step, the first one. So in the next batch step, because we have configured accept policy as no failures, so it will process only those records which are succeeded in the previous batch step. It will not process the records which are failed previously, because accept policy is no failure. So from record number 1 to 7, all the records will be processed by this batch step again, and the records which are failed will not be processed by it. Okay. So in those cases, we used to configure accept policy as no failures. Now guys, the next accept policy is only failures. So from the definition, you can see batch step processes only those records that failed to process in a previous batch step. Like from the definition only, I think it's clear, but let me show you. So guys, let me explain it to you. With the help of one example when we used to configure accept policy as only failures. So guys, again, let's say we have 20 records in the input that we need to process with the help of a batch process. And out of those 20 records, 10 of last 10 records failed in the first batch step. Okay, 1 to 10 are processed successfully, but from 11 to 20 got failed. So let's say if in this another batch step, if we configure accept policy as only failures, so whatever records which are filled in the previous batch step will be processed by this batch step, the another batch step, the preceding one. Okay. So guys, let me explain it to you with the help of one example when we used to configure accept policy as only failures. So guys, let's say we have 20 records in the input, and out of those 20 records, let's say first 10 records are processed by this batch step 0, the first batch step. Okay, and from 11 to 20, those records are failed in this batch step. So those failed records will be handled by this another batch step if we configure accept policy as only failures. So it will accept only those records which are failed previously in the previous batch steps. So in those cases, we used to configure batch step as only failure because it used to process only failed records which are failed in the previous batch steps. Okay, I hope you understood. So guys, the last one is all. So when we used to configure accept policy as all, so guys, from the definition only it's clear. Batch step in this case processes all the records regardless of whether they are failed to process in a preceding batch step. Okay, so let me explain it to you with the help of one example. So guys, let me explain you when you will configure accept policy as all. So guys, again, let's say we have 30 records this time, and out of those 30 records, first 15 records are processed successfully by batch step 0. Okay, the first batch step, and the another 15 records are failed here. And let's say we have configured a batch step as all. So regardless of whether those another 15 records are failed, it will process all the records which are passed including the records which are failed in the previous batch step. So basically it will process all the records. Okay, I hope you understand. So to understand more, okay, we will do some POCs in upcoming videos. From there I will explain you each and every term with the help of the use cases which I have designed for you. So these are the multiple use cases I have prepared. With the help of this we will understand each and every concept. Okay, thank you guys. I hope you understand everything in this session. Okay, okay, thanks, bye.